change my hat. Our next, no. Our next presentation will be from Erwin A Rezelman. He is Chief Business Officer of Fixposition AG. With a background in finance, but a passion for technology, Erwin has worked in Europe, Asia, and North and South America, setting up software development centers, delivering smart city Internet of Things solutions, and connecting technology to insurance. He has worked in well-known global companies and ran startups, including his own focused on big data and IoT. Since last year, he is the Chief Business Officer at Fixposition, the Swiss-based leading provider of positioning technology. The Fixposition Vision Fusion technology provides precise positioning everywhere, including in degraded and denied GNSS areas, enabling autonomous platforms to operate efficiently. And I guess that has a good touch base with the ODD discussions that yesterday we had. And today, his presentation titled Enabling Autonomy Through Precise Positioning. Please.
Thank you very much. I'm glad we got this funky little headphone working again. That's the part I was really looking forward to be honest. Thank you. All right. So I am not an engineer. I've worked in technology for 26 years or so, but I want to show you an application more focused on the solution side and how we solve some of the challenges that we meet. I know yesterday there was a big debate about how precise do we need to be and does it really matter? Well, in agriculture it does matter because you might be mowing the wrong part or sowing the wrong seeds, but we'll see that a little bit later and I'll show you some applications as well. So the first thing is, where are we working right now? So where are we actually applying our solutions? So on the one side is on the agriculture side, and many different applications, the different seasons that of course they go through. The other part is the utility robots, the self-sweeping, the garbage collection, and all these different things that are now also automated. Then the commercial landscaping. So this is, the old sit-on mowers, which actually are great fun. I sat on one, but now are being also autonomy. They drive themselves, and we don't want wires in the grounds or anything like that. And what we've also been working on is more in the construction side, in the mining side, where there's also the same challenges, and I'll come to the challenges in a minute. And then you have the indoor-outdoor situation. So you might be outdoor, then you go back indoor, then you go back outdoor. And that, of course, also is a whole new area that is being automated as well. Now, what is the challenge in all those situations? The challenge is that if you are in a city environment, you have the urban canyons. So you have buildings that are reflecting the GNSS signals that they are supposed to be receiving, or they're blocking it, which means that you have intermittent areas where you have no connection. No matter how good your RTK provider is, no matter how wonderful the satellites are above you, you just have a blank space. You're blind. The same thing when you are working on a farm. So you're driving close to a barn. You are driving under trees. You are driving under foliage, for example, in an orchard. You have the same challenge. Then the same thing is when you need to go in and out of buildings, maybe to pick up a new attachment, maybe to drop something off. So all of these situations have that blind spot, and that is really the challenge that we're trying to solve. To be honest, if you always have great GNSS coverage and great RTK, this is not your solution. Very simple. You don't need it. But in most cases, there will be these blind spots that we need to solve. So this is an example. And this is a lot of data we actually got ourselves. So we have data that we have collected in Europe, in the United States, and also in Asia. So thousands and thousands of kilometers to help also train our system. But here you go, you have a wonderful GNSS connection. This is a stadium. This is a ground care situation. So the device goes in, there are certain areas covered, and with GNSS you can see the yellow orangey line. It's all over the place. That is not the real trajectory that the vehicle actually drove. Now I add to this the fixed position solution. So I blotted out the GNSS because it's no longer reliable. We need an alternative solution. So in this case, it switches to our deep fusion engine, and it takes in the wheel odometry, it takes in the visual odometry and the IMU, and from the initial position that it had with a great GNSS connection, it then does an automatic switch and continues with a decimeter accuracy indoor until it goes back outside or from under the covered area to get the GNSS signal again. So that is the blue line, as you can see. And that is up to a few centimeters, the actual trajectory of the vehicle in this case. This was filmed, by the way, in China. So we did this one in China at the stadium there. Now, I included this. This is also data that we have collected. GNSS outage is a real problem. All the red marks means we have either degraded GNSS or no GNSS that we can rely upon. So we need to cover those. This is forested areas. This is in between buildings. This is going in and out of structures. And you can see there are a lot of red pieces on there. Even if the red piece is only a few meters, it can make a huge difference in the accuracy of your product, the efficiency of the work that needs to be done. At this point, I know that seeing is believing, so in a minute I will play a little video for you. But one of the sectors that I've been looking at is the more mid-market. So there are some great high-end solutions out there, but they are 10 times more expensive. You will see we don't integrate LiDAR, radar, because for our customers that makes it a lot more expensive and it no longer is economically viable for them. However, we are not using super duper IMUs. We're not using very expensive high definition cameras because they're not necessary. So we're trying to keep the compute power low, cost low, energy usage low, because the worst thing that can happen is that you drain the battery of whatever autonomous device you're running just because you need to run some high computational power. We don't need a map. So I like SLAM. I think that's a great solution. But in this case, you can deploy it right away. You don't need to do any mapping in terms of being able to get the positioning. So let me play this here for you. So the blue line is the fixed position solution. The orangey line is a high-end RTK INS, and the yellow line is the RTK GNSS. So you will see right now the RTK GNSS is off on its own trajectory. The orange line will be off in a minute as well. There we go. And in a minute, all of them will be gone. So this is a problem. You can see the camera information. You can see the situational awareness that it's doing there, the feature recognitions. You can see it going inside, covered areas, going indoor, going back outdoor. But you have an issue if you only rely upon the GNSS side. Now, of course, this is now being used around the world. We have customers in different areas. Some, as some of you already said, oh, I cannot give you my full customer list. We have the same challenge. With some of them, we're doing specific projects to make things work, to integrate our product with them. Mainly OEMs or ODMs, so the manufacturer or the designers of these devices. We don't work directly with growers or with other companies building the roads and so forth. But you can see some of them over here, the little utility robots, which is through a company that creates platforms. Pix Moving is a Chinese company. We have Greensy over here. They make lawnmowers. They're based in the United States. Also related to that, we have the Bobcat and Skag all doing lawnmower or large lawnmowers. And then we have several agriculture robot companies as well. Both in the vineyard, also in the areas of the orchards and sowing and plowing. So I don't worry, I'm not going to play the video of the CEO of Greensea. We also work with several global companies. So Segway Ninebot, for example, is also an investor into the company. They create utility robots. They also create little vehicles to do last mile delivery and so forth. Then Movella, you may know them better from Xsense, so they make IMU chips, and they still do that today. Together, we're offering the what we call the Xsense Vision Navigator, which is actually, I forgot my thing over there, but Adriana will hold it up for you. So this is the, the same product that they are reselling. We will come up with a solution using their IMU. We have a very low-end IMU right now, again, based on keeping the low compute power, but we will come up with a solution with theirs as well. And then U-blocks, which we mainly use for our GNSS chips that are inside the actual unit there. Now, some comparison as well is nothing bad, nothing good. I think all of these solutions have their value. We are obviously addressing the areas where you need to have positioning to a level of precision of 10 centimeters. So that's where our solution works best. But you know, you can use SLAM, but you do need to make a map every time you go into a new area, which requires quite a lot of computing power compared to the computing power that we use. The same thing if you use the RTK IMU, it's brilliant, it's a great solution, but if you don't have a connection, then what do you do? So again, in some areas we have no value to add because you need this as that, but in the area where you need to have the precise positioning and you potentially have outages because of buildings around it, trees, or other obstacles that impede that connectivity that you might need to have at all times. So I am, by the way, I should say, I am not a professor. I do not have the research documents to go behind all of this, so if anybody wants to ask me that, I can, of course, direct you to some of our guys in the business and R&D who did do the research. I just don't have that available for you, but we did do actually some studies there as well. Now, how do we actually then offer the solution? So the product that Adriana there was holding up a minute ago is what we call our starter kit. That is ready to go. It has the GNSS antennas, it has the suction cups, so you can plug it on top of your device. It has the sensor unit, which has the camera, the IMU, and the GNSS receivers on there as well. There is an additional connectivity for you to connect wheel speed, though wheel speed is not essential, but it's something that helps you provide a little bit more accuracy, though it's not very helpful when you're out off-road and the wheels keep slipping and so forth. So that's why it's not essential to give you the decimeter level positioning. But that's ready to go. So it comes out of the box, you connect, and off you go. Now, if you say, well, this is really working for me, I can see this working, you can go to the next level and say, well, now I just want the sensor unit that I'm going to do what we call the design in. I'm going to put it into or opt different solutions. Or if you do a larger volume, you can actually just go to the OEM board and you connect your own sensors to that, including the camera and the GNSS. The same thing if you use the sensor unit, you attach your own GNSS antennas as well. Now, of course, if you say, well, this is great, I'm going to implement this in my new product line, then you can go to the next level where you just use the software module. This is a product that is not on the market yet. It's what we're working on this year. And this is very important if you look at the commercial lawnmower market. So the small lawnmowers, which are about 1,000 or so, for them form factor, price sensitivity is very, very important, and those are very high volume. So it's a very different kind of market to look at as well. And we have actually done quite a lot of work in that and enabled quite a few of the smaller lawnmowers as we speak. So this is kind of the evolution that our customers are going through today. Is this always going to be like that? I don't know. I think we will probably skip some of these steps going forward, but it is, you know, having this unit all in one was very helpful for your first customers to say, well, can I test it out? Does it really work before committing? And then, of course, you have the production cycles of their new products to also bring in later. Some new services that we are currently developing and will be adding is an indoor start. So one of the big debates we have from customers, okay, I'm parking my device inside and then I start from there. Or, for example, you have a forklift truck, it starts indoor because it needs to pick up pallets, and then it goes outdoor to put them somewhere else. So how do you feed your indoor positioning without having a GNSS fix? So that's one of the solutions that we will be offering this year. Post-processing, this is really if you're running similar tracks multiple times, the post-processing helps with further accuracy, further learning as well, and mapping. This is not SLAM, but this is map on as you move, and it's very helpful for indoor, for example, and it's helpful if you are running the same path multiple times. So it improves the efficiency. Actually, the picture that you saw earlier on the start is actually one of the maps that what it looks like when we look at it on the computer vision. Okay, I think I went back as well. Okay, yeah, so that's that. And then you'll be happy to know, I know that we're all looking forward to lunch. So I don't have as many slides. So this is already my last slide. So why do we think we can add value in this discussion that we're having today? One is to cover those blind spots in a cost-effective way, easy to implement, fast to implement. Also, I think importantly, you don't need to set up anything in advance. You don't need beacons. You don't need to have maps to make this work. And I think we've got a lot of experience now with ECTEC, the very large machinery. You know, one of the big elements with that is vibration, for example. If you put them on a tractor, the whole thing is like it's drunk when you look through the camera. So we have some software solutions behind that to manage that as well, and where to place it and so forth. You know, during the breaks, we had a discussion with most of you. We talked about rain, we talked about snow, we talked about darkness. So obviously, you know, when the light goes off here, nobody can see anything. Our system can't see anything either. There is no radar, there is no infrared, so darkness is darkness. However, the customers that use our products usually have headlamps of some sort, so we do have light. If you have rain, yes, rain impacts, but unlike LiDAR, it doesn't say I'm in a collision or I am in a problem here. It will know that this is rain and it can see through that. Snow, yes, if the snow goes against the lens, you need to find a way to clean it. But, you know, in agriculture, there's very few people who work during the snow time. Dust, yes, dust and dirt that splashes up. That's why we normally recommend our sensors to be higher up. That also works better for the GNSS reception rather than very low to the ground. So, yeah. I think that is in a summary of what we do. So if you have any challenges where you need to cover those blind spots, we're happy to discuss. We have a unit here, and we can show you what it looks like. It's very small, it's light, and it's available. And as I said, we have customers around the world already using this. So thank you.
Thank you for your presentation, and I believe you added to the existing viewpoints that yeah, we have this kind of different methods and different applications for different positioning methods. Maybe again I use the opportunity and ask the first question that when we use this signal, do we have some way that we know that this data that comes now from the unit out, is it based on more based on camera, or is it more based on the GNSS input? Is it possible to distinguish if we want?
Yes, so as part of the algorithm, it continuously compares the information that's coming in from the GNSS, and it always compares to a millisecond ago, where did it think I was? So we create our own algorithm to measure. And when it jumps a certain percentage, it automatically switches to vision. And you can see that in the log, when it switches to what.
Oh, great. Any question from audience?
By the way, you also asked me about our investors. I put them up there for you.
I don't have a question like this. Do you do loop closure on the vision side, or is it pure odometry that you're running?
Say again?
Do you do loop closure on the vision side, or is it pure odometry that you're running?
Pure odometry.
Can you comment on drift per distance?
Yes, it's about 0.75% over distance.
Thanks.
Is it vision only or vision plus?
Vision plus IMU. And wheel odometry if you connect to wheel speed as well.
That is easy. When you give exact numbers, then there is no really point of extrapolation. Any other question? Oh, okay.
That's a simple one. Do you have any plans to integrate other type of sensors, not only cameras, for example, radars for snow?
So we have some customers that have asked us to do, and we're currently doing a trial with a LiDAR and our sensor. So, you know, if our customers want more, we're happy to test. We do have an ability to attach other sensor inputs into this. The question is just the cost, and our customers have said, okay, I don't want to pay for all that extra stuff, but the customer that we're working with already has LiDAR, so there we do integrate.
Okay. Good one.
Next question going from platform, Philip Lindner. Does your model need to meet any regulatory requirements?
It does not, but we are CE certified and FCC. We are finishing right now. Oh, and we also have the IP, I don't remember which one, but the waterproofing, which has also been certified, because if it goes outdoor and it leaks, that's a problem.
Great. And second question from Philip. Do you detect should your system or the vision degenerate? Do you detect should your system or the vision in case it degenerates?
Sorry, I can't see that properly. I need my reading glasses. That shows my age.
So is it degenerate somehow? And how you can detect it?
So as we are measuring always the rail position over distance, if we're not using GNSS, yes, then we know when it degenerates over time. And also we can do the post-processing, so we can record actually what it is seeing and what it is measuring, and we can use that also to measure that. What is very important, we don't store any data unless you want to for study. So the camera will look and then immediately delete. So it's not keeping that data, doesn't go up into the cloud either. There is no need for that. But we do have the option, and you could see that in the video I played for you, where we can replay the actual scenarios and improve from there. I'm not sure I quite understood or answered.
Philippe, thank you. From
Yeah,
Philippe.
okay.
Yeah. Any other questions?
You can speak in stereo.
Hello. Yeah. Do you plan to use the video to identify some specific feature, like a QR code, for instance, which could be geolocalized? It could be great for integrity of the signal.
Yes, so that is what we're working as part of the indoor start as well, to be able to recognize QR codes, but you can do a lot more with QR codes for other purposes as well, and some of that I cannot share yet until it's available on the market.
How long?
Yeah.
So any other question?
Remarks, maybe?
I know everybody must be hungry and ready to go check out as well.
Well, you already got 5 questions. I guess that is kind of
Yeah, maybe one more. So you obviously have north and east and heading from the, like, similar to GPS. But how about roll, pitch, yaw, elevation? Are you trying to estimate those?
Yes, so the IMU and the barometer helps us do that. We have some scenarios where a self-driving platform goes into an elevator, for example. Then the vision doesn't help much, so we need to estimate through the barometer how high the actual device went and where it needs to get out.
That sounds promising. So I guess we are done with the questions, and then we can head to lunch. And please be back